Alrighty, week 5, starting next week. I know. Hopefully you're all getting used to this concept, right? That I lecture a week ahead. For you all, for the online students, not so much. Okay, so there's always class topics, but this week I'm going to try to minimize them. Okay? Oh, that's not what I wanted to do. Let me go back here. Try this. So one thing, when I had you all do the Google Doc security audit, remember me talking about that? I wanted to make sure you had it. I intended for you to tell me if you had it done right or not. And most people just like, oh, yeah, they just took notes on how. I'm like, no, right? So I really want you to tell me if you did it right. Now, I'm not going to make you do anything this week, but I really want to have you have this set up correctly, okay? And I went last week and talked about it, but as I'm looking at classwork as it's coming in for week 4, I'm like, okay, I must not have been clear. Because you're telling me the steps, I'm like, yeah, good, you have the steps, but really I want to make sure you're sharing correctly, right? And here's the deal, if I can't open your documents, I can't grade them. Really, really important, okay? So making sure you have that right. So I almost, when I put this lecture together this morning, I was thinking, well, you know what, let's do it again. And I'm not going to make you do this, but this is a way you can verify it. Is if I went to the directory, I was wanting to say if I shared it correctly, you get a link right here, and you could put that link in your classwork, and I could tell you if you did it correctly, okay? So again, I'm not going to make you do it, although I'm so tempted, right? But I'm not going to since I already covered it last week, but I just want you to know that, right? And the other thing is I know, and this was the next item I had, was on the My IT Lab Google Doc that I have you all creating, right? For reporting your My IT Lab. I noticed about 70% of you did it the way I asked, which was you created a Google Doc and then you start putting your print screens in there, right? And then you're telling me when you submit it what your scores are, right? That's cool. Some of you are just getting me print screens. And I get it, because sometimes it's like, it's okay just to give me a print screen, but in My IT Lab, I did want you to give me it in a doc, okay? So in this case, who do you share the My IT Lab doc with, or what directory would it go into? Yeah, shared with Rio. It wouldn't go into the shared with everyone. Not everyone needs to know that. It's just you and me. It's between you and I. So I'm not going to get hard-nosed about this, but you may see me in your My IT Lab doc actually say, hey, why didn't you do it the way I asked, right? This is a teacher in me too, right? I want you to do it the way I ask. Teachers, we're crazy like that. So I want to show you something I've been meaning to show you for a couple weeks that I didn't. How many of you know what the Control F does in a browser? Yeah, what does Control F do in a browser? It searches. Like, let's go to the screen real quick. Yeah. Oh, by the way, let's show them. Wave to those online folks. Hey, everyone. All right. So then go to the screen. I'm on a discussion board, which our discussion boards, how many of you have noticed, can get pages long, right? And sometimes you're wondering, did I do the replies? And by the way, I bet there's a keyboard shortcut to go to the end. But let's say, and this is not just true for Canvas, this is true in general. When you're looking for something on a web page, right? You're searching for a term you want to know if it existed. You hold Control and you hit F. So put that in your notes. Control F is really handy to have and to know how to use. So if I wanted to start searching, I searched my name and I found that 16 of you in this first page mentioned me, well, including me, okay? So that's good. It also will tell, so what's the other thing you could use this for? You can see how many replies you've done, right? Because remember, I don't grade until you do the 2 required replies. So if you're wondering, hey, I did the main post, why hasn't Rio replied? That's probably why. I go back and search to see if you did both of the replies. But in general, like I said, this works on any web page, okay? And you ever had a web page that's so long and like this, but in general you're trying to find a specific thing and you just don't want to scroll through? The other thing this functionality does, and switch to the screen, it'll actually take you to those locations, right? So not only does it tell you how many times it occurs, it actually takes you to those locations in the doc, which is probably more helpful than just telling you how many times it occurred. But that functionality I think is really good to know that it's there and how to use it. So let me just see how many of you already knew that. 1, oh good, several, and everybody else new to you? Yeah, okay, so good. Hopefully you got something from that. So this was the topic we left off last week. Let somebody read it to me again. What does it say?
types of people in the world?
There are only 2 types? It says 10.
Yeah, 1 and 0 too.
1 and 0 in what?
Binary.
Right? So this week we will drill down a new level into binary, okay? And hopefully by the end of today's lecture, you're going to be in the group that understands binary, okay? Because from here on out, you'll hear me talk about referencing, bits and bytes and what this means. So this is just a reminder, right? So a computer is an electronic device, typically run in a binary form. So again, how many of you, well, I'm not going to ask, but if you haven't, you're going to watch the other short video for week 4 where it actually drills down and talks about the different encodings, because I talked about bits and encodings, right? So this is true for everything on the computer that you use. It has to come down to that kind of format. And what is this? What does this represent? The power on, but really, what does it really represent from now on? 1 and 0, which is the binary digits, right? So computers, because they are fueled by what? Electricity, and electricity has how many states? 2, on and off, which is why you need a binary system so that you can represent what we understand to the computer, because the computer by its nature does not understand what we understand. We have to always tell it. So I thought it'd be kind of just a moment. Let's do this and put this in your notes. Generations of computers. So this idea of how we store this 0 and 1 is really the demarcation point for every generation of computers. And last time I mentioned that qubits. Anybody remember me mentioned qubits at all? Yeah, so what's the thing about, why might we go to, because right now we have bits, we have a binary system. Why might we go to qubits? Leakage, limitations, because the current materials we use are going to not handle the continuing of what law? Oh, good, that is at the atomic level of Moore's law, right? When Moore's law says technology does what? Doubles every 12 to 18 months. Now again, we could or could not debate whether that's a good thing. It just is. So just for a second, and I don't like to do a lot of history because I don't enjoy it that much, but okay. So the first generation of computers, this was how they stored the 0 and 1. This vacuum tube. So what do you think this says about computers in this generation? They were big and it was hot, right? Because there's electricity that either on or off in these lights, which by the way, the term computer bug, how many have heard that term? Computer bug comes from here because bugs used to climb up in these things and make them go out. That's no joke, that really happened, it's been documented, right? So it's true, so the first generation was what? Vacuum tubes. Second generation, look at the size difference here, right? So this is a transistor. So what happens is computers get increasingly smaller and increasingly more powerful. So increasingly smaller and increasingly more powerful. So these are transistors that we stored that 0 and 1. We could store many more of them. It didn't take as much electricity. Huge jump in technology, right? So the next generation was what we call the integrated circuit. So now we were able to store even more of these zeros and ones, and even a smaller platform using silicone and a lot of other stuff to make this stuff work. Okay, so first generation vacuum tubes, second generation was what? Transistors, third is integrated circuits. Good. So that kind of brings us up to current. So really now we have this thing called a microprocessor. And we're going to talk about the microprocessor today. And I love this image. It's one of my favorite, right? Because many people, when they talk about the microprocessor, they talk about that it's the brain of the computer. So prior to this, here in POL4, everything that the microprocessor does for us today used to be different, bigger, bulkier parts. So when we got everything integrated into one chip, wow. So and now there's chips in everything. Everything there's chips in now, right? So again, this idea and understanding, you know, again, this if when we go to the next level, it'll be interesting to see how this changes as well, okay? So this next one, I found a little cartoon. I thought it was kind of interesting. Anybody know Dilbert? Yeah. So, I invented a quantum computer capable of interacting with matter from other universes to solve complex equations. Holy mac. That's actually part of the reason quantum computers could really do this stuff. According to chaos theory, your tiny change in another universe will shift its destiny, possibly killing every inhabitant. Well, shift happens, so fire it up. So I laughed, you didn't, that's cool. Right? So when I read this, I was thinking, this is really true. I mean, as computers, remember me telling you about the intelligence of computers, and as they get more and more intelligence, the more and more things they can do? We have to really think about, right, is that a good thing, right, in our lives, right? I mean, again, you guys are all tainted by science fiction. You think the computers are just going to be horrible, and they're going to take over, and, you're not going to have a job. No, right? You're just going to have a different job. You're going to have a different kind of thing that you do. But who knows what the future is going to bring? We know change is coming. We know we are in the middle of exponential change. Okay, so that was what in your notes? This was generations of computers, right? So I want to talk about the big three today, because if you understand these three devices and how they work in a computer, and let me just say, everything I'm going to talk today, we could talk about in terms of not just the desktop that you're working on, the laptop that you have in home, but also the cell phone you have in your pocket. Okay? But again, over time, everything gets what? Smaller and more powerful. What fits in your phone, what fits in your pocket today is 10 times more powerful than what fit in a room years back in the 1950s. Wow, that's amazing. How did we get that to do that? So here are the first ones. So first, the CPU. I talked about it just a minute ago in terms of, it is the demarcation point for current computers, because we were able to integrate all these other external things that we used to have to manage into one chip, so everything can happen on one chip. But here's how we talk about processors. We talk about them in terms of hertz, and we talk about them in terms of cores, okay? And we talk about them in terms of speed. I forgot to add that to that. So really, today's computers, hertz is just a cycle. And actually, I gave you an image here because this is true. Metronome, right, for those of you in music, right? So when we talk about the processor, we talk about it in terms of its cycle, what it does, and it has a cycle that it does. And this hertz is just that indication of that cycle. So if I was to try to figure out how many cycles per second my computer would process, do you might know how I'd figure it out? It's actually something I've already shown you guys. Yeah, go to the screen. So if I go to computer, and I think it's right click here. Okay, not the one I wanted. If I go to here, and I go to right click, and I go to properties, this computer right here has got an i5. It's got a 2.9 gigahertz processor. Okay? So let's talk about what these things mean. So i5, right, would indicate the number of cores. So you would think how many cores based on that? 5. Not true, I think. And then we can verify this. Let me show you. And we're going to play with these things today. I'm going to do something called, once I can get on there. Matter of fact, how many know what this screen is? Task Manager. If you've ever been, most of the time, if anybody's ever been here, it's been to do what? Stop an application that wasn't responding. But man, there is so much information you've lost if you didn't go venturing out. So let me show you. So if I go to performance, how each of these represents a core. So an i5 has how many cores? 4. Why didn't they call it an i4? Right? So part of what happens is when you start to understand some of the technology, it's like some of it's just marketing and you have to try to get past it because it doesn't make sense. An i7 is actually, I think, 6. So when you look at this, okay, so we have 4 cores, we have 4 brains on one chip. Each processor, each core can run how many gigahertz? We saw it on this screen right here. Anybody remember? 2.9. So here's what this means, if you can grasp this concept. The metronome, right? So 4 cores, each core running 2.9 gigahertz, which means 2.9 billions of things per second. So you got 4 cores running each 2.9 billion things per second. Holy mac. Can you grasp that? How fast that is? Most of us can't, right? That's like beyond what we're really, and again, the metronome, I really love the metronome because that really is, when I see people talking about this stuff, they're talking about that, right? This thing that's just going. So what is it doing, right? Well, first, anything you ask it to do. That's why, depending on your computer configuration, which I'm going to show you a little more about today, you will have different experiences based on what you have loaded, right? Your processor could be hecka fast, but if you're gaming, what does that mean to you? The faster your computer, what? If you're a gamer, the less likely you're to die, right? That's why gamers want fast computers. They want to do well in the gaming environment. You want a fast computer that's doing billions of things per second, multiple cores. Here's the dirty little secret in the industry, though. Most software doesn't take advantage of all these cores now. We keep building all these cores into processors, but software hasn't kept up yet. Software lags behind taking advantage of all these cores. You with me? Okay. So the processor, we term speed is in gigahertz and the number of cores. Good? You got something in your notes about that? So the first big device is the CPU, okay? The second one is RAM. So RAM is so important. And here's why. I'll show you a little bit the relationship between these three things. But in terms of RAM, we talk about it, the speed in terms of nanoseconds. So what that is, right? And again, we're going to get back to binary in a minute, but I'm just kind of giving you the lay of the land, right? So it's measured in terms of how quickly we refresh the binary 0 and 1 that is held in it. But terms that you will hear is like DDR3, DDR2, DDR4 is more current. But in general, what's good for you to know is how much do you have and how much are you capable of adding, okay? How much do you have and how much can I add? And do I need to add? And I'll show you some ways to kind of figure that out today, okay? Desktops, pretty easy to add memory. Laptops, still kind of easy to add memory. The key is you got to know what it's capable of doing. And then there's a website I was looking at today called, I think it's CPU-Z. And it's a utility you can download, and it'll tell you how much RAM you have and what kind of RAM you need to upgrade if you want to. This is generally easy and relatively inexpensive way to get your computer to run more efficiently. By the way, am I talking really fast? No? You good? Okay, ask me questions, please, because it helps clarify. So now that we've talked about this, the size of this, right? So the size of RAM can vary in terms of the way we talk about it, but it's either measured in MB or GB. So now let's talk about that term, because most of you may have seen this, but really this is what it means. So 1 bit, right? Well, on or off. 8 of them together we call A, and this was in the video, a byte. Okay? So 1,000 bytes is a kilobyte. 1,000,000 is a megabyte. 1,000,000,000 gigabyte. 1,000,000,000,000 a terabyte. And 1,000,000,000,000 is a petabyte. That petabyte doesn't have a good name. I think that's got to get some better marketing. Really? You didn't get that joke either? Okay. So in terms of space, right? Now RAM, and we're going to talk about this same measurement in terms of the hard drive, but let's just talk about in terms of your files. Let's say you wrote a 4-page essay. Which of these measurements do you think it'd probably fall into? Kilobyte. Okay? Right? And how about an audio file or sound music file? Megabyte? Video file? Gigabyte? Super Bowl and all the commercials? Terabytes, right? Do consumers need terabytes of storage? Do you? Yeah, and this is becoming a reality these days. When you buy new computers, and now we're going to talk about the hard drive in a second, right? You might need it. Now, why do you need it? I don't know. What do you know if you need it. And not only that, it's just becoming a viable choice these days to get something that big. For those of you that take a ton of pictures, right? Or you do a ton of movies, you need a ton of space. Now, how many of you, and I hate to ask, but I'm going to, how many of you, let's show them for a minute, do backup? How many of you back up? 1, 2, 3, 4. Okay, everyone else that said no, raise your hand. Okay, say it with me. I understand. Say it with me. I understand that by not backing up, I could go home today and everything could be gone. You feel the pain? I don't know. Do you feel the pain? Right? So you need to be thinking about, again, right? There's external devices. There's other ways to do backups. There's various methods for doing backup. There's using the cloud for backup, right? But you just want to understand that whatever you have stored locally, and you want to know how much information you have stored locally. Let me just show you. I just want to show you. If I wanted to ask a question, matter of fact, this might be a good thing for us to do as part of our kind of, every classwork I give a little bit of hands-on. But, matter of fact, I had you already do this, didn't I? When I asked you how much of your, right? So if I said, in this case, right, this drive has 119, how much? Which, by the way, giga means what? Anybody remember? Billion of bytes. But this doesn't really tell me where my data is, right? If I drilled down into here, and I went down into users, and I went down into the login, which I think is here, where would I see how much data my personal stuff is taking? Which directory? Probably documents, right? But I could just do it from here. I could just do this, right-click properties. So this tells me, not a great example, but you get the idea, hopefully, that my documents on this computer, which, by the way, if we did this for my own personal computer, much bigger. Way crazy, okay? So, but for this computer, it's 2.46 gigabytes. So what could I use to back up? In this simple example, what could I use to back up that much information? What kind of devices? External hard drive, absolutely. USB, right? And at least having it copied once somewhere else is a backup. So just in general, I want you to know how to find that stuff. It might be a good exercise for you, and just put it in your notes. I'm not going to make you show it, but just put it in your notes. Find out how much space your data is taking on your system. Okay, back to here. So we talked about capacity measurements, and we were talking about it in terms of RAM, right? But let's just talk a little more about RAM, and then we'll talk about the hard drive. So why is RAM important, right? So RAM is really, and this is the way we talk about RAM, it's the waiting room. Because what you're going to see in a minute is that processor can't really hold very much. It can only hold what you're currently doing, really. So everything that's available for you to do has to be setting in RAM for the processor to get it. And the reason is RAM is really fast, because that 0 and 1 is electricity. And you all know this, right? But if you are working late at night and the power goes out and you didn't save, what happens? You generally lose your work, but Microsoft figured out we do this, right? What do? They actually have automatic backups, right? To try to help you out of here. But in general, right? So, but the RAM, and this just talks about it, right? It holds data that's waiting to be processed, as well as program and instructions for processing that data. So anything that you need to do has to be, you want it setting in RAM so it's fast. But I'm going to show you a real world example of this to help bring this concept home. First, you want to know how much RAM you have and how much RAM you have available to you. And I'll show you how to figure that out. Okay, so RAM is important. Really put it in your notes. All you need to know is it's a waiting room for things to get into the processor. So RAM is a waiting room to get into the processor. It stands for random access memory. That's not as important, right? And the other thing I want you to know here is it's relatively easy to upgrade. You just have to know. You might remember me saying what? Well, how do you upgrade your RAM? You need to understand two things. How much your motherboard is capable of and what kind of RAM you need. And sometimes you can take out chips that have less capacity and put in chips that have more capacity. How many of you have I lost? How many have I lost on this conversation? A little bit? Thank you for being honest, right? So most of you are tracking. That's cool. Ask questions. Okay, so that's RAM. So the hard drive, these days, we talk about hard drives. It used to be, and by the way, hard drives, right? Hard disk drives actually have movement. They move. Boom, boom, boom. So anytime you hear movement in a computer, you should say decrease of speed, decrease of reliability. Anytime something's moving, it could either, the motor could break, which is not you can't really see it well here, but you notice this is the hard drive because it's got a platter. And that platter is moving around, and when you ask for something, it has to find that thing and bring it through the bus system into the RAM, into the processor. So this is it's not old school yet, but I'm going to tell you in the next couple years it's going to be. Because here's what's coming is solid state. So let me just give you the verbiage I have here, right? So then these are longer term storage devices, obviously, and I'll show you what that means in a minute. But a hard drive is either HDD, hard disk drive, SSD, solid state drive, or a combination of the two. These days you can buy a drive that has a part of it that's solid state and a part of it that's moving. By the way, any guesses for what you would tend to put on something that's solid state versus something that's not? Typically you put your operating system there because it's the thing that gets hit the most. So you would, if you had, and I think somebody here or somebody in one of the classes this semester was we were looking at their system properties, and we couldn't figure out why. He had multiple drives, and we figured out that he had this kind of situation where he had a hybrid. So SSD is faster by far, okay? Solid state storage is just like a USB stick, right? You guys carry around, some of you carry around these USB sticks. This is just that in a hard drive in a much bigger capacity. So it's more reliable because there's no moving parts, but it's a little bit more expensive. But again, we're quickly seeing this change, right? And so you get more capacity generally with a hard disk drive. Now, speed in this case is measured in transfer. How quickly can we get stuff from that device into the system, right? And now we come back to the measurement again, right? So we measure this in terms of generally, gigabytes or terabytes. Okay? Good so far? So we're just laying the land. So what are the three, if you were to review just real quickly, what's the three big devices in your computer? CPU and hard drive. Okay. So now let's talk about in the binary system, because this is the whole thing about helping you understand the binary system. We talk about how we represent the binary system in terms of these big three. So in the CPU, we talk about it in terms of absence or presence of electricity. So there is a lot of electricity moving between that CPU and that RAM and all other parts of the system. Which is why if you've ever opened up a computer, often the processor will have what's called a heat sink on top of it because there's so much electricity moving in and out of that thing. And it is, in this case, volatile, which means if the electricity goes off, anything in there, bye-bye. Okay? So the binary system on the CPU is represented by absence or presence of electricity. Remember that light, the Halloween light, right? Remember we talked about if it's on, we're sending a message. If it's off, it's just this expanded out to encode everything that the computer's doing. By the way, same thing for the RAM. The RAM, same as the CPU, it's volatile. It is represented by absence or presence of electricity. Now this is where it gets kind of fun, because the hard disk drive, the binary is actually represented by magnet. Oh, I left off particles here, magnetic particles. And it's not volatile. That's how come when you save things to your hard drive, they're there when you come back after it's powered off. Right? So once you save something, a file to your hard drive, it has these little magnets, and it's either a plus or a minus magnet representing the 0 and the 1. And so that once you write to that, boom, it's there. And some people call this permanent storage. I don't, because there's nothing permanent about a hard drive. It could die, but it is long-term storage, right? So solid state is a similar concept, except that because it's not moving, it's just what we call an open or a closed gate to represent that 0 and 1. Okay, so just review. CPU, we represent it how? The binary system. No? You guys didn't get that? How do we represent the binary in the CPU? Electricity. Yeah? RAM? Same thing. Hard drive? Magnetic particles. Solid state? Open and click it. Which, by the way, do you know when you put a USB, and this is a memory stick into the computer and you're writing to it, you should always properly eject it before you pull it out? And that's part of why. There may be something writing to it, and if you're writing to it and it doesn't get to actually do this process, it could wipe things out. And I gotta tell you, I'm not always the best at this. I'm like in a hurry, I grab it, and I actually have ruined a couple that way. So, in general. So that's the lay of the land. But now let's talk about, so now hopefully you have a concept about these things, and when you're going to purchase a computer, right, these are things that you look at. But now I want to talk about it in terms of this. When we move from the longer term storage, which is either of these two, to the CPU, and this is important, speed increases, right? So anything on that hard drive is the slowest thing to get to. Faster, RAM, the fastest, the CPU. Because how many remember me saying how many things in this computer were happening per second? Billions. 4 times 2.9 each, right? We can multiply that up per second. It's the fastest thing, but it has, in this case, this is in the next image, it has very little memory. The CPU, right? Memory capacity increases this way. But, so there's not a lot of memory, hardly any, in that CPU because of the way it has been manufactured and how we've developed it over time. Which, by the way, this is not completely true. Anybody know of another memory that's actually between the CPU and the RAM? L1 and L2 cache. Okay? Again, if you're studying computers and you're studying networking, you're studying, you're going on in the computer field, you're going to learn a lot more about this the more you study it. I'm just giving you an introduction. And I'm guessing how many of you kind of had a vague idea of some of this before we start into it? Good, a couple of you. So hopefully most of you are getting a general introduction. So why is this important? Right? Well, I'm about to show you why this is important. But in general, speed increases where? From the hard drive, CPU, speed increases, memory capacity this way. Which, by the way, memory is actually both your RAM and your hard drive. So when people say how much memory you have, you kind of say which device? My hard drive or my solid state drive or my RAM? Okay, now let's do some real world examples. Okay? How do we look at this stuff? So let's assume for a second the computer is powered off, right? There's no power going to it. Right now, when the power is, before it's turned on, where does the operating system or Windows, where is it? Hard drive. And how is it stored, assuming it's a hard disk drive? Magnetic particles. Could we, even now that it's booted, but just consider it for a minute, could we figure out how big Windows is? How much space it takes on that hard drive? Could we? Yeah. Very much like I did before. I'd go to computer, I'd go here, see that? Right click, properties. Is it done yet? 26.2 gigs. That's how big Windows is. Right? So when the computer's turned off, what does it have to do? It has to go through what's called a boot process. Okay? And all this is that in order for that Microsoft Windows, for you to work on it, it has to go through this process of saying, there's this thing called BIOS, basic input output, and it says, hey, is everything on the computer ready to go? Anybody ever turn on a computer and it beeps? You had it beep? Keyboard is either out, missing, mouse is out, or your RAM is out, or something else. And actually, each series of beeps tells you what the problem is. So BIOS is there to say, hey, post, power on self-test. Go do the post. Make sure everything's good to go for the computer. How many of you ever looked at the screen when your computer's turning on for the first time? Yeah, you ever seen screens that look like this? Let's see, they're called, I'll go to images.google.com. And what we would call them, BIOS screens, something like that, right? So actually this is inside the BIOS. This is if you hit, often you'll see hit F2 to get into the BIOS, right? So this is what that looks like. Even though most people never get in there, right? This is saying, right, this is where my CPU is, this is where I have L1, L2 cache, I have a hard drive, so all that setup stuff BIOS reads, make sure everything's good to go, right? And actually I think what I was looking for was the startup screen, so probably that's what I'd want to go here, is PC start screen. Yeah, something like this. So the next time you turn on your computer from cold, meaning it was powered off, look at that screen. See what it's saying. Because it's generally counting up the memory, and then it gives you an option to go into that BIOS setup. But most people don't even, they go right past it, which is totally fine. But now you've learned about it. So once it says everything's good, then it starts to load the operating system, okay? And then the system configures, and it loads utilities, and then boom, the user logs in. Okay, so that's what happens, but let's go back here. Go back here. Again, where, before the power was hit, where was Windows setting? Hard drive. It was magnets. So when the boot process happens, what happens to Windows? It moves to the RAM, but does all 26 gig move to the RAM? Heck no, because how much RAM did my computer have? Did we look at it? Did we look at how much RAM it had? Anybody remember? No? Let's go look, just because it's good to know. So this has 8 gig of RAM, right? So that boot process is not going to take all of Windows, it's going to take just a part. The part generally is referred to as the kernel. So only a part goes into RAM, right? So now, what's the difference between, and by the way, the same is true for Word. When you click, and the difference is this boots up and becomes available. A smaller version of Windows is loaded into your RAM. We could figure out kind of how much. And then when you click on Word, right, a smaller version, we could do the same thing with Word where we look at how much space it takes, but when you run it, it goes into RAM. But what's the difference between it being here and it being here? What's the difference? Because what's the difference between the hard drive or the solid state and RAM, which is fast? Say it again? Yeah, RAM is volatile, so if power goes away, it's all going to go off, and it's faster, right? In order for you to do anything, it's got to get into the processor, but we need a smaller version setting in RAM for it to get into that processor. Now, what I'm not showing in this screen, I'm about to show you in Task Manager, because it would be lovely if that's really all that happened when you boot up your computer. But it's not, because notice all this stuff down here? This stuff is setting here. And the more things you load on your computer, the less RAM you have available to you, the slower your computer. This is why generally the fastest your computer ever is the day you get it. Because anytime after then, you load things, it starts to take up your resources. That's not a bad thing, it's just the reality of the system. Okay? So let me show you. Let me show you in this example. We were in Task Manager. Anybody remember how I got into Task Manager? How do you get in? Control Delete. By the way, Mac users, you have something similar. It's called Activity Manager. Okay? So Task Manager. So here we go. We talked about this earlier. And by the way, here's where you normally get here and you end a process and that's all you ever see, right? But in this case, we're going to go beyond that because we're going to look at these processes and this services. Because these are all the things that get loaded on your computer once that boot process is complete and you've logged in. This is all of it. And check this out. Look at this memory, right? So if what I'm doing is I'm clicking on memory and it's sorting it. So what's getting most of my memory right now? Chrome. And every tab of Chrome gets its own little service here. So that means the more tabs you open, the more resources you get. Anybody ever noticed a point at your computer when it really starts to dive in performance? And that's generally when you've loaded more than it can handle. Okay? So in this case, the other thing, there's actually something called services, and these are just services that are running in the background. And they too are taking up your valuable resources, right? So when you power this stuff on, and let's go over to performance. Now we can look at, remember 8 gigs, right? Cached. I have a little more than half of it available to me. And what do I have loaded? What's really the only thing I have loaded here in my computer? You saw it. What's this? It's just Chrome. But it's not just Chrome. It's look how many tabs I got. Do you think Google, Gmail takes up a lot of memory? Oh yeah. Oh yeah. Right? You guys getting this? Does it make sense? Yeah? So why am I telling you this? I'm telling you this because many of you will encounter your computer starting to slow down. So I'm going to show you something that I don't recommend, although I do it. And there's 2 things. When somebody calls me over, because it happens, I don't do it as much as I used to. Somebody calls me over, oh, Rio, I got a new computer. I want you to come help me set it up. I'm like, what is there to set up? They're like, no, I just want you to show. I go, there is so much bloatware that you all get when you buy a computer these days. Unless it's a Mac. And even Macs starting to come a little bloated, right? So what I do is I go to their computer and I do this. Start msconfig. Anybody know what I'm about to do? I'm going to go to startup and look at all these things. Somebody luckily went already and got through, and I disable everything. And what that means is the next time it boots up, I guarantee you it's going to be faster. But what's the downside? We have to figure out if I need these things or not, right? But I start with them, done. Or the other thing I do when I get a new computer, I load it fresh version of Windows, not the manufacturer's version of Windows. Because the manufacturer is going to give you all that bloatware stuff. This is setting out there, taking your resources. By the way, how many of you use iTunes? iTunes helper app? You know about that little guy? Sitting there, waiting, asking, did you plug in your iPod yet? Did you plug in your iPod yet? Oh, if you did, let me open iTunes for you. And it's taking up way too much space. Matter of fact, I think they finally, because I've been asking them to do it for a while. Oh, they did. Look, they took the iTunes helper app and they stopped it from running. So again, all the iTunes helper app is helping you do is open up iTunes, and you can do that on your own. Oh my God. Right? So do you understand what I'm saying here? Is it that you don't understand? As a matter of fact, in my 12 class when I taught it a couple years ago, I used to make students go through and research, not this, but what was heading out, taking most of their memory, and what was taking their CPU, right? So first I'm going to look at what's taking my memory, and then I'm going to look at what's taking my CPU, which, by the way, right now, most of my CPU is what? Can you see the top one? It's called system idle. It's not doing anything. It's just sitting there waiting. Again, billions of things per second it could do. There's really nothing I'm giving it to do. But once I hit a Chrome, by the way, let's do this. Watch this. Let's go to performance, and let me start Word, okay? And let's watch what happens. Uh-oh, happens so fast. Very nice. Happens so fast. I didn't look at it before. How much memory did it have before I started Word? Anybody remember? Oh, we could look at it. 3.2. So we added already some up. Not only that, we can see the processor kind of bumped up because it has to get involved. But again, this is a really 4 cores, a lot of stuff going. It shouldn't take a lot of resources to start Word. I kind of tell you, go home today, look at this thing and see how much of your resources it takes just to open Word. And that will tell you how relative fast your computer is. Okay. With me? How is this different on a mobile device? How is all this different on a device like this? Is it different? Not really. Well, you ever notice when you turn on your mobile phone, it has a little splash fun thing, right? That's just the BIOS, really, and the same concept. right? When I turn mine on, my little Android thing makes me so happy, right? And then what happens is the system boots, gets everything that and every time you install an app, typically there's a service hanging out in the background, which is why the more apps you load, the slower your phone becomes. How many of you have had to reset your phones? Yeah? Me too. I do it just sometimes to make it faster. Because it does, it becomes faster. So the other thing I want you to know, and this is where I'll end today, is I got you all enrolled in this program called Dreamspark. Okay? So Dreamspark is a free program from Microsoft where you can get you guys get that through the campus email. And this is the higher-end software from Microsoft. Oh, not there. My bad, right here. Right here under business. Oh, under business. Called Dreamspark. You all should have gotten an email this week. I did it on Monday. Did anybody see one come through their email system from Dreamspark? Hopefully he did it. If not, I'll follow up with him. So here's why you might want to get Dreamspark. If you're in a situation where you want to load a new version of Windows, you can get Windows 7, Windows 8, Windows 10 for free, right? So if you want to load a clean version of Windows, which I highly recommend, you can get those things for free just by being a part of this class. Okay? And it's not as if it's going to go away after this class. You can get it for here to eternity. So I've all enrolled you in the program. You can get in there, log in, download the stuff. Now, what should you do, though, before you reload Windows? Back up, right? Because it's going to wipe everything out. So if you're not backing up, again, the reason I had you raise your hands was I wanted you to know if you're not backing up, there's a downside. But again, if you want to do something like this, you definitely want to do that. Okay, did you get something from today? Anybody walk away with some new stuff, or was it worth your time today? Yeah? So, now, how many of you would be willing to tell me if we've moved you to this camp? Do you at least have a little bit of understanding more than you did before about binary? So, in the processor, how do we represent binary? That 0 and 1 is what? Absence or presence of electricity. That is volatile. Electricity goes out, it goes away. In RAM, same. Hard drive, magnets. Solid state? Yeah, gates, right? Which is better, a hard drive or a solid state drive? Solid, by the way, go to YouTube and do some just comparing between hard disk drives and solid state drives, and they took two computers, same computer, put a solid state, put a hard drive in one, and watch how quick difference you can see between them, right? It's worth a look. So if you, one upgrade you can do to your computers, if you don't want to have to go buy another one, is get a new drive. Get a solid state drive if you can. Okay? Say it again? It is, right? So that's the downside too. It's like, yeah. Yeah, so I think, we're seeing the prices starting to come down, but really it's kind of like when you bundle it with a new system, that's when you probably want to really look at that. All right, let's say goodbye to them. And say aloha, or what is it? What is it? No, aloha. What is it in Hawaii? You can say it both ways. Nobody remembers? Not even me? Is it aloha? Okay, so I was right. All right. Peace out.